Hello, Pamela.
Hey Fraser, how's it going?
Good. It's been a couple of weeks and you've been a little sick.
Yeah, I got the flu.
Oh, you lost your lower third. We don't know who you are. Could be
Oh,
anybody.
that's true. I should look that up.
Yeah, you got what? Like H1N1, the dreaded
Yeah.
lurgy? What was it?
I'm pretty sure it was the H1N1. I know I was exposed to people who had H1N1 and yeah, it was gruesome. My husband was also sick. So we were a house of all the coughs. All the
Yes.
coughs.
And then you sent that joy out into the world.
I did. I did. I had house guests while my husband and I had the flu.
Oh, you know what's crazy is I'm the one with the kids with the little plague rats picking up all these diseases at school and bringing them home and getting me sick. But I think for the first time, you caught one of these before I did. So
Yeah, and it wasn't even because I went somewhere. My husband went on a business trip and pretty much his entire company got sick.
oh
It was an all
yeah,
company, all hands meeting and yeah, they were able to watch the propagation from patient zero through the company basically.
everybody go get your flu shots.
At least here in the States, not all the varieties of flu that are going around are in the flu shot, and that's what's really causing the problem.
Yeah, yeah, no, the flu's a
So,
tricky one. So
yeah.
it's just I'm just clearing my throat. I'm fine, everyone. Oh no.
If you make me laugh, I'll cough.
Uh-oh.
No
I
laughter allowed.
All right, so risk I'm willing to take. Um, all right, well, so we got 332, which is the one we're going to record today, and then we got to catch up and sort of get this week's episode or next week's episode, and that's going to be 333, which is smashing planets together. And then I'm going to be traveling next week, so we're actually going to try and record 334 as well this week. So if you're watching this right now, get set for an unusual week with a lot of astronomy cast at strange times. More details to follow. But this is part of our like never miss a show, put them out on time commitment. So this is
We
this
we
is what we're
goofed
doing.
last week due to the swarm of invading Satan spawn of virus particles,
Right? Yeah,
but
yeah. It was a tough
we
one
shall
to.
catch up.
We will catch up. Okay, great. So if you've never done this before, we're about to record a live episode of Astronomy Cast, episode 332, Stellar Collisions. We are going to be smashing stars together and enjoying the outcome.
Or at least
Uh,
discussing how the universe does it. 'Cause I personally don't have the wherewithal to change the momentum of a star.
well, can't all be star smashers. So yeah, so we're gonna do that. Then we're going to. I don't think we have a lot of time to stick around for any questions today, but by all means, sort of use the Q&A app if you're watching this episode and post any sort of mistakes, any comments, any questions. Talk amongst yourselves, and if I can, I will try to sort of incorporate that into the show. So because I know Pamela's got some all apparently amazingly all that work that you didn't do while you were sick, nobody did it for you.
Right, exactly. So I came back to, oh my God, everything must be done today. And yeah,
Yeah, it's all still there. Can you check your microphone in the settings? Because I don't think it's the.
this
Yeah,
isn't the one.
it is sort of the one. Can you just double check?
Yeah, hold on. It
Some,
says it's using the right mic.
okay, or in the Hangout or in GarageBand.
And not both. What sounds wrong?
It sounds a little tinny. It sounds a little it doesn't sound your normal rich and luxurious voice. It sounds a little.
That may be my internet. I'm on campus.
Okay, all right. We'll blame the internet, but as long as the local recording is getting done.
Yeah.
Okay, great. Okay, cool. Well, you're ready to go. Any reason to not do this thing?
No.
Okay, I'm gonna press record then.
Okay. I am fighting with Word. Okay. I'm pressing record.
It is working.
Yes.
All right.
Maybe.
Hello,
No.
Preston.
Why is nothing coming in? There's absolutely no audio going in to GarageBand.
See, something's weird. Sound.
Testing, testing.
I think people can agree with me that it sounds. I hope the people watching this can agree with me. It sounds a little funny.
Testing, testing, testing. Does that sound better to you?
Sounds exactly the same.
Okay. Well,
It's definitely coming from your microphone, but it sounds like your microphone is like the gain is way down. Something's unhappy.
no, all of that looks the same.
Okay, as long as your levels look good in GarageBand.
Let me... Testing, testing. Yeah, everything's fine now.
Okay, all right.
It wanted mono 2 instead of mono 1.
Okay.
I'm recording now.
I'm not. Now I am. Okay.
Hi, Preston.
Hello, Preston. Enjoy. Okay, here we go. Astronomy Cast, episode 332, Stellar Collisions. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. How you feeling? You were a little sick last week.
I was. Today is my first day without taking all the cough and sinus and everything medicine, and so I seem to have my brain back and my voice is mostly back. Unlike last week where I sounded like I'd crossbred with a garbage disposal unit. It wasn't pretty.
No, and we were trying to catch up, and we were like, "Can we?" You said like, "There's no way I'm going to be able to record on the Monday." I'm like, "Could we record maybe on the Wednesday?" And you're like, "I think so." No, there's no way we can record on the Wednesday. And then on the Friday, I think so. No, there's no way you're recording on the Friday. Like you literally were not even getting out of bed on the Wednesday, and there was no way you were going to record without going into a coughing fit on the Friday. So we just sort of had to pull the plug, and now we're gonna catch up this week. So
I think I slept as much last week as in the entire month of December.
Yeah, good. Well, you needed to rest, and now, as I mentioned in the pre-show, fortunately, someone came along and just did all your work for you, so there's nothing to catch up.
Yeah. No.
Yeah. So I just want to sort of thank everybody who has been emailing me and commenting on all of their favorite science fiction books. Like, going through the Arthur C. Clarke two-parter was a chance for everyone to let us know what they love to read, and it was just terrific. It was so great to get all these recommendations. I literally now have my reading material set for the next, I don't know, forever. But thanks to everybody for getting, sending us your suggestions. I love it.
And one of the things that I love and hate is how easy it is to get all of these books now through either Gutenberg for the really old ones, through Kindle for new things, and at the same time it's so frustrating because we don't have bookshelves the same way we used to. So loaning books is more difficult. But
yeah, or have time. Yeah, I know what you mean. I'm terrible. I'll buy stuff and just never read them. And I don't feel bad about them piling up in my house anymore because they're just, they're just digits. They're just bits. They just sit in a computer somewhere. Anyway, so thank you for keep them coming. What I'm saying is keep them coming because I need more. All right, let's get rolling. So out here in the Milky Way suburbs, stellar collisions are unheard of. But there are places in the galaxy where stars whiz past each other and collisions can happen. When stars collide, it's a catastrophic event, and the stellar wreckage is visible half a galaxy away. So is this going to happen? Or is the sun going to collide with something?
No.
Okay, great. Because we're in the suburbs. It's boring out here. Nothing really happens.
That is entirely true.
Yeah.
But no, we live in the suburbs, and as near as we can tell, the statistical probability of us impacting anything is as close to zero as it can get.
Yeah, it is literally, I don't know, firing grains of sand from the opposite sides of the United States and them happening to collide with each other. Like it's
as if you managed to throw a thing of sand from Vancouver and get in my eye in St. Louis, which is made even more challenging because I'm inside a building.
Right. About the same odds. But there are places in the universe, in our Milky Way, where this kind of mayhem does go down.
Yeah, and this is one of those things where when we talk about stellar collisions, there's basically three different types. There's the first thing that comes to your mind, which is star kind of hanging out by itself and gets whacked for no obvious reason. Then there are binary stars, where you have two stars that formed together, lived together, and then became hateful towards one another and collided. And then you have an intermediate situation, which is not galaxy clusters, globular clusters, where you have thousands to tens of thousands of stars, all very tightly packed together, and two stars that may not have formed together eventually end up passing close enough together that they form a new binary system later in life. And those systems, just like the naturally forming ones, can also collide and lead to stellar mergers.
Well, let's start with that first example then. So you're talking about just, one star hanging out, doing its thing, and then another star comes out of nowhere, wham, runs into it.
Yes.
So, I mean, I think we can all imagine this in our mind. Perhaps me more, I can really imagine this. But like what's the scenario? What would happen? What would set this up?
This is one of those fluke things that incredibly rare odds of happening. You either have just two orbits that have poor timing, so as two stars orbit around the galaxy, their paths cross at the same moment and place in time. Same moment and same place. Time is the same thing as the moment. Or you have galaxies colliding. In the process, orbits get changed, things end up crossing. This is not something that's statistically supposed to be something we need to worry about. But it can happen.
Well, it's a big universe, and so something
universe.
Horrible is happening to someone somewhere.
All the time.
All the time. An infinite amount of time, something horrible is happening. Stars are colliding all over the place. If you look out billions of light years to the hundreds of billions of galaxies that are out there.
So while this is the least likely to occur, it is the one most often imagined. You see it in science fiction books. You see it in all sorts of different things. Collisions between stars. Not likely, but possible.
So what would happen then in this situation? So you've got just two random stars, splash. So what would happen?
So in the most improbable case of they have sufficient center of mass on center of mass action that they don't end up spiraling around each other, but they actually pretty much collide in one momentous kablooey. It will literally go kablooey in the form of some sort of a nova. You throw all of this mass together, it's going to radically change the type of thermonuclear reactions that can go on. You're going to have radical changes in the pressure of the system, in the temperature of the system, and depending on the types of masses involved, you're either going to get a system that completely annihilates itself or simply flares out and leaves behind a new type of star as a remnant. The latter case is what's going to happen if you end up with a tiny star falling into a larger star or two smaller stars coming together. That's less exciting, but how exciting it is will also depend on what is the difference in velocity. So you have to take into consideration not just the mass of the two systems, but they could be coming together fairly quickly.
Right, and so I guess I just imagine just the huge velocities involved. But if you sort of very slowly poured one star into another star, you would end up with the combined mass of the two stars, and then whatever. I guess as a baseline, you'd get what would that turn into if you had that, and then you add on top of that all of the velocity and densities and things like that, right? So if you just carefully poured one star into another star,
which the universe does for us on a regular basis. So when it comes to the nice, slow, gradual one star eating another star, we've got lots of examples we think of that. When we look out at globular clusters, we see what we call blue stragglers. This is stars that are unusually blue, which indicates unusually young for the age of the system that they're located in. We haven't totally caught one in the act of becoming a blue straggler, so there's a few different theories for how they came into existence, but one of the main theories for where blue stragglers come from is you have a binary system, and the stars in the binary aren't that massive, and they're very close, and over time They slowly either suck matter one from the other, or they slowly get close enough that they merge into a single star. And that single star bloats up nice, happy, bluer than you would expect. And so you end up with this unusual composition, unusual color from a nice, gentle merger.
Right, but I imagine the situation. You've got these stars that have been living out their life in the main sequence phase to a certain extent for as long as they have. They've used up X amount of the hydrogen in the core. They've turned it into helium. They're just the standard thing. I mean, if you bring this other star in and you collide them together, is it just going to literally reset the clock on the star? Is it going to
Pretty
bring it
much.
back to it's going
Yeah.
to be a freshly born star again with
It,
nice hydrogen all mixed up again, and it's time to begin
it's
fusion again?
unclear what happens in the nucleus. This is one of the really neat things for people who are trying to model the insides of stars. You're going to end up essentially with two stellar nuclei, two stellar cores, orbiting one another within a shared envelope for a while. How quickly those two nuclei merge into a single nuclei, that's going to shake up the entire process. You're also going to end up with the new nuclei has some form of mixed up composition that will both include the nuclearly enriched materials from the processes that have already been going on. But it's impossible to imagine one of these situations where you don't also mix in more virgin material from the envelopes of the stars. So yeah, it's going to reset the clock to a point, but you're still going to end up with this star with a really strange composition.
And is this maybe what we're seeing with these blue straggler stars, right? That they've gone, someone's pressed the reset button on a star
Yes.
that should have been dead
Or at least
billions
more
of years ago.
evolved. Or at least more evolved. I mean, these aren't big stars, so dead is stretching it, but they definitely shouldn't have been blue. They should have been significantly more red, significantly more evolved. And just sort of hanging out being elderly stars instead of being young and excitedly blue stars.
And so I'm guessing the outcome then is really going to depend on the amount of total mass that you're dealing with. If you've
Right.
got two solar mass stars, you're going to end up with, when everything's said and done, twice the mass.
And it's also going to depend on what are the things merging. So blue stragglers, we're pretty sure, are two run-of-the-mill, fairly moderate-sized stars that ended up combining. You end up with a large star, but not supernova candidate material. But everything that occurred was a star when the merger took place. Other situations that we worry about are what about when red giant stars and white dwarfs end up merging together? So
What happens?
Well, depending on how it occurs, you can either end up with the white dwarf sucking material off of the red giant star until it generates a giant thermonuclear reaction that we refer to as a type 1a supernova or type 1b supernova. Another possible situation, and again, this is like the blue stragglers. We can't catch the stars in the act, so this is strictly a theoretical, well, maybe this explains what we're seeing. There's a class of variable star called R Corona Borealis stars. These are stars that are hanging out, shining quite nicely, and suddenly plummet in brightness. Their magnitude gets to be a larger number, which means they become significantly fainter. This is tied to some sort of dust production in the envelope of the star. They're really hard to understand, and one possible explanation for them is that there's a white dwarf star merging into the envelope of a physically larger, lower mass star, and this is churning up all sorts of unusual behaviors.
Wow. I mean,
Yeah.
when you think about these binary pairs, you get this white dwarf companion with a star, and it's siphoning material off the star. It's happening over millions of years, right? It's slowly building up, and it hits that 1.4 times the mass of the sun, hits that limit, and then detonates as a supernova. But if it's like going right into the star, it's going to be accreting that material very, very quickly, getting into that envelope, right, where it's getting actually surrounded like an all-you-can-eat buffet.
And it, depending on the mass ratios, it might not actually hit that supernova point. You can have a very small white dwarf star, you can have a low mass red giant star, and they may not hit the kablooey mark. And in the process of falling into the red giant companion, that white dwarf may puff back out. And if it's puffed back out, suddenly that electron degeneracy pressure that causes the supernova, well, if it's puffed back out, pressure's gone down. So you no longer have those same constraints. Lots of things can play in. And it's this whole parameter space of, does the white dwarf puff back up? What's the total mass? All of these things together, as these stars merge, as these stars collide, determine what we end up in the outcome.
Right, and so maybe we're pressing the reset button, maybe they're detonating a supernova, maybe all kinds of crazy mayhem.
Right.
Okay, so we talked about, just the crazy stars just smashing into each other, talked a bit about blue stragglers, and we started to talk a bit about binary pairs, but like what kind of environment will we be seeing for that to come together? Because I can kind of imagine, like, you got two stars and they're just orbiting each other or orbiting a common center of gravity. Unless something happens, they're just going to do that forever, right?
Well, and that's the thing, is it turns out that lots of binary stars have slowly evolving orbits. In some cases, the evolution is caused by the fact that pretty much all stars are undergoing mass loss. Our sun is regularly losing mass. The bigger the star, the more mass it's going to lose over time. As those two stars lose mass, gain mass from one another, how they orbit one another is also going to evolve. There's also going to be moments of inertia that come into play as you have giant star contracts down to little tiny white dwarf. All of these things affect how they orbit one another, the drag that they experience from dust and gas in the system, how much material they absorb from their companion star. And so this means that even though in a nice simplistic view of binary stars, you have two little centers of mass that just orbit one another in the exact same way over time as the two stars evolve, no. This whole thing is going to be changing over time as the separations between the stars evolve. And this means that it's quite feasible to imagine that the stars slowly get closer to one another, that one star ends up creating drag on the other one by gravitationally sucking material off of it. And all of this can lead to the one star eventually consuming the other star.
That's what I'm imagining, right? Is this red, one goes first and turns into a red giant, and maybe the two stars just formed really close together and they just haven't collided yet, and then the one reaches the end of its life, it puffs out its atmosphere bigger than,
Orbit of Jupiter.
Orbit of Jupiter, right? And now that star used to be completely separate and there was no drag on it, and now it's inside or rubbing against or really close to that other star, and now things are going to go south.
And they do. And this is where, as I said, one entire family of supernova comes from. We see recurrent nova, which is where you have small compact objects, neutron stars, white dwarfs that develop accretion disks of material. They're sucking off their companion. Those accretion disks periodically get dense enough that they flare up, give off lots of light and energy. That itself isn't a stellar collision, but over time that affects the orbits, and it's totally feasible for you to end up with shared envelope where the two stars get close enough that they bloat each other up, essentially heating one another. Essentially, with binary stars, if you can imagine it, it can probably happen.
Right, and I can think of like all kinds of outcomes where, as you said, like one goes off as a red giant and then it interacts with the other one, and then maybe they create this shared, you mentioned this shared envelope, or one absorbs material from the other, or the combined mass detonates as a supernova. I mean, it all depends on the raw ingredients of the interaction, right?
And we thought we had a good understanding of all the different ways that things can go wrong. And then we saw V838 Mon. This was a star that back in 2002 went from being a completely boring star that no one paid any note to suddenly it became one of the brightest stars in the entire galaxy. And this flash of light that it gave off radiated through surrounding shells of material. And in desperately trying to understand what was going on with this really weird star system, it was determined that this just might be a case where you had a run-of-the-mill star hanging out, minding its own business, and it didn't go through a nice gradual merger. It simply went through a merger, like that merger, flash of light merged. It's unclear if it consumed a star, if it consumed a planet, if it consumed multiple planets, but unless it undergoes a second nova-like event, one of the best explanations we have for why the heck this star did whatever it did was that it was a stellar merger. So the universe is still finding new ways to surprise us.
Now, we've talked about one extreme environment, which is these globular clusters. I said that wrong. Globular clusters. You guys are infecting me. But what about the center of the Milky Way and the center of galaxies, where you've got stars orbiting the supermassive black hole like planets going around the sun? It's really dense.
And so in these situations, we do occasionally end up with things falling into the supermassive black hole. That's fairly rare as far as we can see in our own galaxy. But we also end up with a much denser stellar environment. So just like with globular clusters, where you see the blue stragglers forming through various types of binary stars coming together, we can't necessarily say what a blue straggler is in the center of the galaxy, but there's no reason to think that the same physics doesn't apply. With globular clusters, the blue stragglers stand out because in a globular cluster, pretty much all of the stars formed at one time, and all of them formed with the same basic material. So when you look at them, you can say, okay, all of these should be the same age. We shouldn't be seeing these overly blue guys over here. When we look at the center of the Milky Way, we can't say that all the stars formed at the same time. We can't say they all formed with the same material. So we can't say, oh, these are overly blue. But the densities are high enough that we'd expect there to be the same sorts of capture events where two stars pass near one another, gravitationally grab hold of each other, become a binary star system, and over time evolve to consume one another and become a blue straggler that you can't tell is a blue straggler.
And then that thing gets smashed into the supermassive black hole, and it's
who knows?
Mayhem all around. Yeah.
The black hole doesn't eat everything. It just occasionally noms on things that have unfortunate orbital parameters.
Yeah, I mean, it's always important to remember that it's just a big gravitational source. It's not like a vacuum cleaner.
No. So in order to fall in, you have to have some series of unfortunate events that lead you to gain an orbit that sends you literally on a death spiral.
So one event that's coming up that's going to test this, this probability is our merger with Andromeda in the next, I don't know, 5 to 7 billion years from now.
The Milkdromeda event.
The Milkdromeda event. So what's going to happen for the stars in both galaxies?
This is one of those things where that type of collision that you worry about is not something that you really actually need to worry about. For the most part, all of the stars are going to just move past one another. They're going to collectively settle into new orbits, and yes, in the center of the new resulting galaxy, you're going to have higher densities, higher frequencies of binary stars, but overall, things aren't going to hit each other. You're not going to end up with a whole bunch of new V838 Mons taking off. It's just not a concern. Now, dust clouds colliding left and right, massive amounts of star formation, material getting driven into the core of the resultant galaxy. All of that stuff's going to happen. Active galactic nuclei as the resultant black hole or binary black hole system in the center happily consumes dust. Yeah, but stellar collisions, very, very low probability.
Yeah, so you're gonna get all of this, crazy star formation and supernovae after that, and you're gonna get this gas and dust piling up, but the stars will just go.
Exactly.
All past each other, yeah. Okay, so we've talked about sort of normal, what we would all imagine as stars, but there's a lot of exotic objects like neutron stars and white dwarfs, and they can collide with other objects and with each other, and so and those we do see a little more often, don't we? Like because they're
And
bright.
and and this is the binary merger situations. This is typically where you have two stars born together, grew up together, one became more aggressive, exploded and did bad things to its neighbor. You can end up, depending on the mass ratio, sometimes with a pair of neutron stars that end up eventually merging, colliding, supernova, black hole, or just kablooey, depending on the mass ratios. You can end up with white dwarf neutron stars, neutron black hole, black hole, black hole. If you can come up with a combination, nature has created it. And over time, all of these things are going to have orbits that lead them to eventually merge. Maybe not every binary system, definitely not every binary system, but every possible combination will at some point have an example of what happens when two stars merge.
But like with neutron stars, don't you have like almost gravitational waves are contributing to them spiraling inward on each other?
You get that with all of the extraordinarily high mass systems. So you get that with the neutron stars, with the black holes. We even start to see that with things where you have a neutron star and a white dwarf. So pulsars is one of the places where we've been able to spot these things. Pulsars are a special type of neutron star that's spinning quickly. The universe is filled with all sorts of exotic matter trying to merge with other exotic matter.
But I think the amazing thing with those is they're probably even more rare, like two neutron stars coming together and detonating as a gamma ray burst, right? But the resultant explosion is so powerful that we see it in galaxies hundreds of millions or even billions of light years away. So we're seeing these incredibly rare events, but they're so energetic that we just see them from halfway across the universe.
Right, and that's one of those things that I have to admit I sort of take for granted is, yeah, exotic matter, it explodes, kablooey. But yeah, when two neutron stars merge, the resultant supernova and gamma ray burst will make that merger brighter than the entire host galaxy that it's sitting in.
And wipe out a goodly portion of the everything in its region.
Yeah, it's the universe. It's destructive. It's trying to kill us.
Yeah, we know it's trying to kill us, and it's demonstrating it by happily scouring a quarter of a galaxy with one explosion. It's crazy.
No big deal.
No big deal. Yeah, universe, I got my eye on you. Awesome. Well, thank you very much, Pamela. That was cool. Next week we're going to talk about planets colliding. Yikes. And then I'm not sure, but actually, someone recommended we should talk about galaxies colliding. I don't know if we have. Maybe we have.
I think we have.
Yeah, I think we have. Anyway, awesome. Thanks again, Pamela, and we'll see you next week.
Sounds good. And we save.
Don't go anywhere.
Not going anywhere.
Let's do a lightning round. Can we do a lightning round of for 5 total minutes?
Yes.
Of questions? Okay. Let me just save my project then. Okay, so thanks. There was a few questions and they're really good. And so, 22. Yay! Saved. Export. Yay. Okay, and I will do my upload. Okay, here we go. Lightning round. When you get like literally 30 seconds to answer each one. Here we go. Can a stellar collision be fairly common and just result in a larger star?
Yes.
Yes. Okay. Done. Zach Cody asks, what would happen if a rocky planet fell into a star? If something the size of the Earth fell into the sun, how would we?
It would go flare. It wouldn't be highly exciting. It would be flare, and then it would be over. You'd see a change in the composition of the star.
Josh Andrews notes that someone needs to smuggle kablooey into an astrophysics paper.
I'm sure it's been done.
Zach Cody says, so in theory, could future humans throw Jupiter into the sun to give it more fuel?
That's less effective than you might want. The real problem with the sun is ineffective mixing. So what you really want to do is figure out how to employ a giant blender to get the
Yeah,
hydrogen
just a
from the
big
outer
spoon and
shell.
just stir the sun up a little bit
Exactly.
more, and you'll get much more benefit. Yeah, Jupiter's like what, 1/1000th the mass of one million. I don't
And
know. It's
it
ridiculously small. Yeah. Let me see. Okay, Graham Sicking says, have we got any evidence of gravity waves from the collision of two neutron stars?
we haven't directly yeah, gravity wave fail.
So far, gravity wave fail.
Yeah, LIGO doesn't work.
So the only gravity waves we've seen so far are gravity waves
Secondary evidence through the decay of
emanating
orbits.
emanating from two neutron stars dancing with each other.
Yeah, and it's secondary evidence from watching the evolution of the orbits.
Uh, Stan Pensek says, I hope H1N1 hasn't transferred from human to Mac. This one might. Pamela has Macs, and Pamela had H1N1. Okay, and this is going to be the last question. So Andy Rational says, about two black holes colliding before they collide, will space between them become unwarped? So if
No.
gravity warps space, would the second black hole undo the warping? Just be
No,
double the
it's
warp.
yeah. So you end up with you have to think of it in terms of 4 dimensions, but you end up with a double dip until the double dips merge to form an even bigger dip. So they're
Yeah.
creating a big dip.
I think the great question that you answered must in a couple of years ago was, what happens if you take you know what I'm going to ask,
Yeah,
antimatter black hole and a regular matter black hole, and you just smash them together? What do you get? Just more black hole, double the black hole. Doesn't matter whether it's antimatter or anything. It's all just the same thing, and it's all just black hole.
it's energy.
Um, okay, Ronnie Person says, if a star
You said
whisks...
that was the last
Oh, that's right.
question.
Okay, last one. If a star whisks past the solar system, would that be bad for us?
Depends on the mass, how quickly it whizzed. So a
Close.
slow moving high mass object passing through the outskirts of the solar system is far more dangerous than a fast moving compact object.
Done. Thank you so much, Pamela. Thank you, everyone, for watching. Get caught up, and we'll probably be recording in a couple of days. So thanks,
Sounds
everyone.
good.
Hello, Pamela.
Hey Fraser, how's it going?
Good. It's been a couple of weeks, and you've been a little sick.
Yeah, I got the flu.
Well, you lost your lower third. We don't know who you are. Could be
Oh,
anybody.
that's true. I should look that up.
Yeah, you got what, like H1N1, the dreaded
Yeah.
lurgy? What was it?
I'm pretty sure it was the H1N1. I know I was exposed to people who had H1N1, and yeah, it was gruesome. My husband was also sick. So we were a house of all the coughs. All the
Yes.
coughs.
And then you sent that joy out into the world.
I did. I did. I had house guests while my husband and I had the flu.
Oh, you know what's crazy is I'm the one with the kids with the little plague rats picking up all these diseases at school and bringing them home and getting me sick. But I think for the first time, you caught one of these before I did. So
Yeah, and it wasn't even because I went somewhere. My husband went on a business trip, and pretty much his entire company got sick.
oh
It was an all
yeah,
company, all hands meeting, and yeah, they were able to watch the propagation from patient zero through the company, basically.
everybody go get your flu shots.
You know, at least here in the States, not all the varieties of flu that are going around are in the flu shot, and that's what's really causing the problem.
Yeah, no, the flu's a
So,
tricky one. So
some of invading Satan's spawn of virus particles,
right,
but
yeah, it was a tough
we
one
shall
to.
catch up.
We will catch up. Okay, great. So if you've never done this before, we're about to record a live episode of Astronomy Cast, episode 332, Stellar Collisions. We are going to be smashing stars together and enjoying the outcome.
Or at least
Uh,
discussing how the universe does it. 'Cause I personally don't have the wherewithal to change the momentum of a star.
well, can't all be, star smashers. So we're going to do that. Then we're going to I don't think we have a lot of time to stick around for any questions today, but by all means, sort of use the Q&A app if you're watching this episode and post any sort of mistakes, any comments, any questions. Talk amongst yourselves, and if I can, I will try to sort of incorporate that into the show. So, because I know Pamela's got some all apparently, amazingly, all that work that you didn't do while you were sick, nobody did it for you.
Right, exactly. So I came back to, oh my God, everything must be done today. And yeah,
Yeah, it's all still there. Can you check your microphone in the settings? Because I don't think it's the.
this
Yeah,
isn't the one.
it is sort of the one. Can you just double check?
Yeah, hold on. It says it's using the right mic.
Okay, in the Hangout or in GarageBand?
And not both. What sound?
It's just I'm just clearing my throat. I'm fine, everyone. Oh no.
If you make me laugh, I'll cough.
Uh-oh.
No laughter allowed.
All right, so risk I'm willing to take. All right, well, so we've got 332, which is the one we're going to record today, and then we got to catch up and sort of get this week's episode or next week's episode, and that's going to be 333, which is smashing planets together. And then I'm going to be traveling next week, so we're actually going to try and record 334 as well this week. So if you're watching this right now, get set for an unusual week with a lot of astronomy cast at strange times. More details to follow. But this is part of our never miss a show, put them out on time commitment. So this is
We
what we're
goofed
doing.
last week due to the swarm